An introduction to exponential functions. What is an exponential function? A function is a relationship between two variables. Variables are letters that you use to represent real-life data. The input variable is normally the x value. This is the data that is given or known, perhaps from research. Perhaps we want to know the output for a particular set of information. The output variable is the value that's obtained after doing something with the input data. Normally we represent the output variable y. The function is written as f of x is equal to 2x. This is called function notation. We read this as f of x equals 2 to the exponent x. The function name, f, the input variable is x, and what happens to the variable is defined on the right-hand side of the expression. There are two categories of exponential functions: exponential growth, which is the focus of this particular video, and exponential decay, which is the focus of your next video. A function can be represented in 4 ways. A table of values. This table shows the x values, or the input into the equation, and the corresponding y values that represent the results. In an equation form, y equals 2 to the exponent x. A graphical representation, the graph, and the last, of course, the written form. The function y equals to 2 to the exponent x. Now, let's focus on the table of values. To create a table of values, you want to create a table that has 3 columns and up to as many rows as you need to calculate the data for. The first column is where we will put the input data, the x values. The second column is where we will put the output data, the result of the calculation. This will be the y value. The third column will be where you can show your calculations. Now, let's take a look at how to create a table of values using this sample problem. You are given a sample of bacteria whose initial population is 100. The population triples every day. Calculate the population for the first 4 days. Organize this information using a table of values. Input x is the day and output y is the bacteria population. Now, step number 1. Create the table, 3 columns and 6 rows. Number 2. Resize the columns. You want the x and y to be relatively small, and the third column where you are going to show calculations a little bit bigger. Number 3, add the headings for each column in the first row. The first column is x, the second column is y, and the third column is your calculations. Now, you want to add the required x data in column 1. We are starting at year 0 and going to year 4, so in the first column we will put 0, 1, 2, 3, 4. This is the data we will use in our calculations. The next step is to enter the initial value for the population. We know when the sample was first given, there were 100 bacteria given. This is the initial value. Now, enter the population for year 1. The population triples. So at year 1, we go from 100 to 300. How do we get that? 100 times 3. It's tripled. Now, number 7. Enter the population for year 2. Keep in mind, every year the population triples. So, in year 1, we had 300. If 300 triples, we have 900, which we get from the calculation 300 times 3. And now, the population for year 3. Again, remind yourself, the population triples. So 900 will go to 2700, and while we're here, let's do year 4. 8100 will be 2700 tripled. And you notice we show our calculations to see how we derive or obtain the answer. And now, what's the conclusion? Well, from the table, you can see the number of bacteria after 4 days is 8,100. Now you know why we get so sick. Now, let's take a look at the second way that we can represent exponential functions, the equation. The second way to represent an exponential function is with an equation. Let's take a look at the sample problem to determine a formula. A formula is a fancy way of saying, you know, an equation. Here's the same problem we already are familiar with. You are given a sample of bacteria whose initial population is 100. The population triples every day. Calculate the population for the first 4 days. Once again, we will organize the information using a table of values. To help us, let's look at what we know. What do we know? The initial value, or the original number of bacteria, is 100. The bacteria triples every day. Now, using this information, let's look at the table of values again, but using a formula this time. Remember, the input X is the day, the output Y is the bacteria population. Again, we start at 0 day, we have an initial value of 100. For 1 day, we tripled. Now, we could represent that as a formula: 100, the initial value, 3, the growth rate, 1, the length of time we're measuring our growth over, 1 year. Now, we can do the same thing for year 2. Initial value 100, triple, 3, and this is year 2. Repeat for year 3. The only thing we're changing in our formula is the day, and that we're representing it with, you guessed it, an exponent. Let's check year 4. Same thing. So we could come up with a formula for n day if we looked at the trend that we have been following. So what is the formula? 100, 3, to the exponent n. Now we have an equation that we can use. So we can say the final amount is equal to 100, the initial amount, times 3, the growth rate, to the exponent n, which is the number of days. Now, let's take a closer look at how to make an exponential equation. Here is the basic formula to use for any exponential function. The amount final, that's the amount you end with, is equal to the initial amount, the amount that you start with, times the base. The base represents the growth or the decay rate. Are you doubling? Are you growing up by 7% a year? Is it a half-life? Whatever it is, you will use that as your base. Time is the total amount of time you are measuring over. 7 years, 3 years, 10 years. It changes. And of course, the period, which we remember from trigonometric functions, is the length of time for one cycle. How long did it take to grow or to decay? In our example, the period was 1 year. We were measuring every year. It tripled. So, next we want to look at the graphical representation. Here is the equation that we derived. Y equals 100 times 3 to the exponent x. And when we use a graphing, so now what we need to do is we're going to take our equation, we're going to put it into Geometry Sketchpad, Decimals, whatever graphing software you're using. And we actually can see now our graphical representation. I've highlighted points A, B, C, and D, as we know what these values are from our table of values. Note that C isn't quite exact. It should have been 2 and 900, and 3 is the same. It's only because it's hard to be totally accurate when you're positioning points on a graph. And now let's look at the third way, the written form. Here is the equation, and we would have the written form as the function y equals 100 times base 3 to the exponent x. And now let's work on some problems. Your next video coming in the series is on exponential decay.